Buckle up, because human sperm have just been exposed bending one of the universe's ironclad rules, Newton's third law of motion. It's a discovery that could rewrite how we think about physics at the tiniest scales, and trust me, you won't want to miss the mind-bending details. But here's where it gets controversial. Could this mean our classic laws of motion are due for a major overhaul? Picture this. Human sperm effortlessly gliding through thick, gooey fluids that should trap them like quicksand. According to a team of researchers led by Kenta Ishimoto, a mathematical expert from Kyoto University, these microscopic swimmers pull off this feat by sidestepping a principle that Sir Isaac Newton laid down back in 1686. Newton, aiming to describe how objects interact with forces, outlined 3 laws of motion, and the third one, often called the law of action-reaction, basically states that for every push or pull action, there's an equal and opposite push or pull reaction. It's like a perfect balance in nature, where forces always come in pairs that cancel each other out. To make this clearer for beginners, think of 2 identical marbles rolling towards each other on a smooth table. When they smack together, each one bounces back with the same force it received. That's Newton's third law in action, ensuring symmetry in their motions. But nature isn't always so neat and tidy. In chaotic systems, like flocks of birds swarming in the sky or particles swirling in a fluid, things get unruly. These are examples of non-reciprocal interactions, where the rules of equal and opposite forces don't hold true because the actions aren't perfectly symmetrical. And this is the part most people miss. Living things like sperm and algae crank up the chaos by generating their own energy. With each flick of a wing or wag of a tail, they pump extra power into the system, pushing it far from that balanced equilibrium. As a result, Newton's symmetry breaks down, creating a sneaky loophole that lets these tiny organisms zoom through environments that would otherwise slow them to a crawl. A few years ago, Ishimoto's team dove into this mystery by examining real data from human sperm and creating computer models of green algae, specifically a species called Chlamydomonas. Both of these critters propel themselves using slender whip-like structures called flagella. Think of them as flexible tails sprouting from the cell body that bend and twist to create wave-like motions. Normally super thick fluids, imagine something as viscous as honey or even thicker, would soak up all that energy from the flagella, grinding movement to a halt. Yet somehow, sperm and algae glide right through. Digging deeper, the researchers uncovered that these flagella possess something called odd elasticity. This special property lets the tails flex and move without wasting too much energy on the surrounding fluid. But that alone didn't crack the code of their propulsion. Through their models, they introduced a fresh concept, an odd elastic modulus, to capture the inner workings of how these flagella manage their non-reciprocal, wave-driven pushes. As the team put it in their study, they explored this from simple, solvable models all the way to the actual waveforms of flagella and Chlamydomonas and sperm, revealing non-local and non-reciprocal forces within the material. Now, why does this matter beyond just sperm trivia? These insights could spark innovations in tiny, self-building robots that copy living materials, or help us grasp the secrets behind group behaviors in nature, like how schools of fish coordinate without chaos. The research, published in PRX Life in October 2023, opens doors to understanding how life finds ways to cheat physics. But let's not shy away from the big question. If sperm can defy Newton's third law, does that mean the entire framework of classical physics needs rethinking? Some might argue it's just a quirk of the microscopic world, while others could see it as evidence that our laws are incomplete. What do you think? Are Newton's principles outdated in the age of biology? Could other everyday phenomena, like how birds flock or even how we walk, be bending these rules too? Drop your thoughts in the comments and let's debate.